Welcome to Book Decoded. Today, get ready to have your mind blown a bit. We're cracking open Joshua Howgego's The Meteorite Hunters.
Yeah, fantastic book. It's not just science, it's adventure, history.
Exactly. Forget dusty textbooks. We're talking human stories, cosmic secrets, all packed into these amazing rocks from space.
How Gigo really tracks how we went from, myths and legends about falling stones,
To actually understanding what they are. We'll dig into some really surprising stuff.
like ancient Egyptians using space iron, or explorers battling deserts.
Right, and how scientists figured out these aren't just weird rocks, but messengers carrying clues about, well, everything, even where Earth's water came from.
So let's start at the beginning, those first encounters. It's fascinating how different cultures saw them.
It really is. You mentioned the Egyptians' Tutankhamun's dagger, right? With that high nickel content.
Classic meteorite iron. And you had nomadic groups in South America who knew about this huge iron mass, the Maison de Fierro.
But in Europe, for ages, the idea of stones falling from the sky was, well, dismissed.
Totally. Considered nonsense, really. It took until the late 18th century for things to change.
Okay, so what were the key events? Siena, wasn't that one?
Siena in Italy, 1794, then Wold Cottage in England the next year.
Old Cottage. That's the one where the guy almost got hit? John Chipley?
That's the story. And his boss, Edward Topham, made sure people heard about it.
A bit of drama helping science along.
And then the really big one, Leg, France, 1803. Thousands of stones.
Thousands. Okay, yeah, that's hard to ignore.
Exactly, even though people like Chladni had already suggested they came from space.
Others were looking for earthly explanations, right? Like volcanoes.
Right. William Hamilton thought the Siena stones might be volcanic, maybe hit by lightning. Shows how ideas evolve.
So Leg was the turning point.
Definitely. Jean-Baptiste Biot did a proper scientific study. That pretty much sealed the deal. These things are extraterrestrial.
Wow. So where did those early important meteorites end up? Are they still around?
Many are. The Natural History Museum in Vienna has a great early collection. Siena, Wold Cottage, Legel samples are all there.
Like a little museum of that scientific shift.
Precisely. Fast forward to today, though, and meteorite hunting is, well, it's quite something.
Still adventurous, right? Like Brule in the Tenere Desert.
Absolutely. Working with Tuareg guides, facing incredible challenges, that spirit is still there.
But it's not all deserts, is it? I've read about hunting them in cities.
Yeah, John Larson in Oslo, finding micrometeorites on rooftops. It's amazing.
Tiny bits of space dust just everywhere.
And Matthew Gange confirmed they were extraterrestrial. Plus, we have tech now.
Like metal detectors.
Useful for irons, yeah. But the big thing is camera networks. VigiSeal, UK Fireball Alliance.
They track the fireballs?
Track them, calculate where they might land. That's how they found the Winchcombe meteorite so quickly.
That's incredible. It's like part science, part treasure hunt.
There's definitely a market. Michael Farmer, the dealer Howgego mentions. It raises questions, too.
Like who owns them?
Exactly. Laws vary. France is different from Denmark, for example.
Okay. And then there's Antarctica, the ultimate hunting ground.
In many ways, yes. Dark rocks, white ice, easy to spot.
And the ice itself helps.
Right. The ice flow concentrates them in certain areas. Moraines, William Cassidy and A&S Met really pioneered hunting there.
But there's that mystery, the missing iron meteorites.
Ah, yes. Relatively fewer irons found there compared to stony ones. The idea is they absorb more sun, get warmer.
And melt their way down into the ice, sink.
That's the hypothesis from Joy and Avat. Hard to prove by digging them up, but it makes sense.
And climate change is affecting this too.
Sadly, yes. The warming temperatures threaten these icy archives.
Which makes studying them even more urgent. Howgego calls them pennies from heaven.
A great phrase. Because the information they carry is priceless. They tell us about the solar system's birth.
What kinds are there? I know there are irons, stony ones.
Stony iron. And then planetary ones, bits of the moon, Mars.
Wow. And within stony, you have chondrites and achondrites.
Correct. Chondrites are the really primitive ones. And iron meteorites have that amazing Widmanstätten pattern.
Oh yeah, the crystal structure. That proves they cooled super slowly, right?
Over millions of years inside asteroids. It's a clear sign they're not from Earth.
And some chondrites, the carbonaceous ones, they have water, organic stuff.
The building blocks, like the Winchcombe meteorite, they're like snapshots of the early solar system nebula.
So they tell us about how planets formed, maybe how Jupiter moved around, all that dynamic early history.
Exactly. Theories like the Nice model, the Grand Tack. Meteorites provide the ground truth, the physical evidence. even for things like early magnetic fields.
Okay, which brings us to the water question. Where did Earth's water come from?
The big one. Comets were an early idea. Some match Earth's water signature, some don't.
What's the signature they look for?
The DH ratio deuterium to hydrogen. It's like a fingerprint. Comet Hartley 2 looked promising.
But meteorites, those carbonaceous chondrites, are now a major suspect.
Very strong candidates, yes. And some research suggests Earth might have held on to some water from its initial formation, deep in the mantle.
So multiple sources, maybe.
It's looking that way. Plus, processes like space weathering on asteroids might actually create water.
Like on Itokawa.
Daly's research suggests that, yeah. And Zelinsky found actual tiny droplets of ancient water trapped in salt crystals inside meteorites.
Actual water from billions of years ago.
Direct samples, incredible stuff.
It's not just about origins, though. Meteorites act like fossils, space fossils.
That's a good way to put it. Finding fossil meteorites, ones that fell millions of years ago and got preserved in rock.
What can they tell us?
Foundkins analyzed fossil irons to learn about Earth's ancient atmosphere, like oxygen levels.
Wow. And didn't Schmitz find evidence of a huge meteorite shower linked to biodiversity?
Yes, around 466 million years ago, a spike in L-chondrite meteorites found as tiny chromite grains in limestone.
And the dust from that might have cooled the planet, helping life?
That's the theory. A direct link between asteroid belt events, possibly nudged by Jupiter, and major changes on Earth.
It all connects. And now we're not just waiting for them to fall, we're going out to get them.
Exactly. Missions like Hayabusa 2 to Ryugu, OSIRIS-REx to Bennu.
Bringing back actual samples from asteroids?
Pristine samples. To understand their makeup, look for water, organics, learn about the early solar system's snow line.
Didn't they, bomb Ryugu?
They created a small crater, yeah.
Oh.
To collect subsurface material, stuff that hasn't been altered by space weather.
That's dedication. And more missions are planned.
MMX to Mars's moon photos, Psyche to a metal asteroid. It's a really exciting time for understanding these objects.
So, wrapping up our look at the Meteorite Hunters, it's just amazing. These rocks hold so much. History, adventure, science.
They really connect us to the cosmos, don't they? From ancient people looking up in wonder to scientists analyzing samples in labs today.
It makes you think, doesn't it? How many more are out there just lying on the ground waiting?
Holding secrets we haven't even thought to ask yet.
Makes you want to keep your eyes peeled for unusual rocks. Anyway, thanks for joining us on Book Decoded.